Other than the fact like a giant like tsunami or something.
All right, so here we go, people. Today, we're not going to have to work with matrices too much. It's more with inequalities. So we're going to graph inequalities and do systems of inequalities and then look at a little linear programming. Why? Because linear programming is used in business and industry to maximize profits, minimize costs, and to help make management decisions. All right. So when you graph inequalities, you graph an equation and you figure out whether you used a dashed line, if it's greater than or less than, or a solid line, whether it's greater than or equal or less than or equal to, and you check a point not on the line to see which side it's shaded on. Okay? You're going to use a checkpoint. Okay? All right. So let's graph this one. So here's a graph. Boom, 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 boom. So I'm going to graph y equals 2x plus 4. Some of the points of that are like 0, 4, 1, 6, and 2, 8. Now, is it going to be a solid or dashed line, Raina? A solid line, because it's less than or equal to. So 0, 4, 1, 6, 2, 8. Going like that. So, what's the easiest checkpoint there is here on any graph? What's the easiest point to check? 0, 0. 0, 0 is the easiest checkpoint. Now, if the graph goes through 0, 0, you can't check that. But since it doesn't go through 0, 0, you just plug a 0 here and 0 here. Is 0 less than or equal to 4? Yes. So it's shaded on this side. Easy peasy lemon squeezy. You did this in Algebra 2. And that's their graph. All right, now we have a systems of equations where there's 2 of them. So let's go ahead and graph these. Are either of these dashed lines? Both of them are dashed lines. Thank you very much. All right, so I'm going to get this one and x, y. If x is or if y is 0, x is 2. If y is 2, this is 6. What plus 6 is 4? Negative 2, so if x is negative 1, it works, right? Negative 2 plus 6 equals 4. Okay? Why did I do it that way? Because this is an odd number. So if I know I put an even number in here, it'll make it even, so then I can make it easier there. If you need to, you can just solve this equation for x because poor Maggie, she's not seeing it whatsoever. So 3y equals negative 2x plus 4 and divide by 3. So y equals negative 2/3 x plus 4/3. So if we put in a 0, well, if we put in a 0, we're going to get a fraction. If we put in a 1, we're going to get a fraction. If we put in a 2, it'll work. 2, 0, and so on. So that's why I just play with numbers here, because I think it's easier. Okay? If you have a little math sense, that's not too bad. So 2, 0 is right here. Negative 1, 2 is right here. So it's a dashed line going down this way. Check 0, 0. Is 0 plus 0 less than 4? So it's going to be shaded on this side of this line. Now, y equals x squared. is the point 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So it's a dashed line here. Can we check 0, 0? No, because it's on this one. But I can check 0, 1. If x is 0 and y is 1 greater than 0? Yes. So it's above this one. So if it's below this one and above this one, it's double shaded right in here. So this is where the solutions are, is right in there. Okay? We good with that? I'm sure Reese is good with that since she's paying so good of attention. Linear programming is where we take and do inequalities, and then we have to check what the optimum situation is, and we check all the corner points because points in between the corner points really won't matter. Okay? Here's a function here, and it's subject to the following constraints, and they say, well, what is the best solution? So here's the constraints. So we have a point here, a point here, a point here, and a point here where they cross. So 0, 19/5 is this point here, 4, 0 is this point here, and they cross at 2, 3 here. So what you do is you stick each one of these in for the f of x. So we try 0, 0, and we get 0. So that's probably not going to be what we want. We put 0 and 19/5 in here. So we get 0 plus 4 times 19/5. Would somebody take 4 times 19/5? So this one's going to equal 0. Take 4 times 19/5. What do we get? I'll take a decimal. That's fine.
476.
I want a decimal. 15.2. We put in 4, 0 here. We get 12 plus 0 is 12. If we put in 2, 3 here, we get 6 plus 12, which is 18. So 2, 3 right here is going to be your optimum solution. Okay, let's see if there's not another linear programming one. Discard. So what I'm going to do is I'm going to go over here, and I'm going to go here, and I'm going to go here, and I'm going to go here. Denied. We'll try that again. Sign in. Then I'm going to show you a linear programming problem here. Okay, here's a linear programming problem. So I want to graph these constraints, okay? So one of my constraints is x plus y is less than or equal to 8. So I am going to graph this. So x plus y is less than or equal to 8. So I go the point 8, 0 and 0, 8, or 8, 0, 8 and 8, 0. And then there's the x-axis is going to be a graph. The y-axis is going to be a graph. And where else? And then x minus 4y equals 0. Okay? So if x is 0 and y is 0, that works. If x is 4 and y is 1, that works. So 0, 0, and 4, 1. So I'm going to graph that. So 0, 0, and 4, 1. 0, 0, and 4, 1. Okay? So my shading is going to be right in the middle of that. Okay? So I'm going to check that first. Nice work, Mr. Bishbach. All right. The minimum is at, so I want to find a minimum for this function. Okay? So if I plug in 0, 0, I'm going to get 0. If I plug in whatever this point is, it's going to be bigger than that. And if I try to plug in 8, 0, or 0, 8, it's going to be bigger than that. So if they want my minimum, well, it's just going to be simply 0 at 0, comma 0. Check. Well done, Mr. Bishbach. The maximum. Okay. Now I got to figure out where these two cross. That'll be interesting. So to figure out where those two cross, I'm going to do this on the board. So those of you watching the video, sorry about your luck. So x plus y equals 8. X minus 4y equals 0. So if we the bottom equation, if we multiply by -1, we get 5y equals 8. So y equals 8/5. If we plug that into there, x plus 8/5 equals 8. Move the 8/5 over. X equals 8 minus 8/5. This is 40/5 minus 8/5 is 32/5. Okay, so that's what this point will be right here is 32/5, 8/5. Okay, if we stick it into this equation of 4x plus 2y, 4 times 32/5 plus 2 times 8/5, this is 128/5 plus 16/5 is what? 144/5? Sure, why not? Since none of you are raising your fingers to punch your calculators. That's 144/5. My other point on the graph is 0, 8. So if we plug it into 0, 8, 4 times 0 plus 2 times 8 is 16. So what's bigger, 144/5 or 16? 16. So our maximum is at 16. Whoops. That was 16, 16. At the point 0, 8. Almost. Even worse. Need keypad. Zero, comma, 8. Check. Oh. What's 144 divided by 5? So then why are you guys telling me the wrong answer? Come on. Jeez. All right. All right. I can't even know where'd my keyboard go. All right. Well, you know what to do. You know what the answer is. Yep. I'm going to get it wrong. Too bad. So sad. Okay. So then this one that you'll hit on your problems. A theater is presenting a program on drinking and driving for students and their parents and other responsible adults. The proceeds are donated to the local alcohol information center. Admission is $12 for adults and $6 for students. However, the situation has two constraints. The theater can hold no more than 240 people, and for every 2 adults, there must be at least 1 student. How many adults and students should attend to raise the maximum amount of money? All right. So, we know we have adults and students. So let's make adults X and students Y. So X plus Y equals how many people? X plus Y equals how many people? 240. Okay? Now, for every 2 adults, there must be at least 1 student. So for every 2x, there must be at least, so less than or equal to 1y. Okay? For every 2 adults has to be at least, so that has to be less than or equal to 1 student. If we had 4, okay. Right. So, Deb, are my 1 and 2 backwards as well? So there's twice. You can have twice as many adults as students, right? For every 2 adults, there must be at least 1 student. So to make this equal to each other, you need 2 times that. No. So 2 times the number of adults equals 1 times the number of students if you have, because you make more money off of adults. So if you have at least, if this is greater than or equal to, you wouldn't need very many students. So it has to be less than or equal to. Okay? All right. So these are our constraints. Obviously, x has to be greater than 0 and y has to be greater than 0, or nobody's going to make any money. Okay? So the amount of money made, and so this is our function, this is our, what we want to know, this is our profit, equals $12 for every adult plus $6 for every student. Okay? So if we graph this out, this line goes like that, and it's 240, 0, and 0 to 40. Okay? This line, 2x equals 1y, so y is greater than or equal to 2x. So 0, 0, 1 over 1 up 2, it goes up like this. So the amount of people should be like right in there. Okay? So where do these cross? Well, to figure out where they cross, we just take 2x, y equals 2x, and put the 2x in here. And so 3x equals 240, so x must equal 80. So if you had 80 adults and 160 students, no. So this one's backwards. So this should be a 2 and a 1. So it should go like this: 160 adults and 80 students. Okay? So it should be this shaded. And so that'll be your maximum profit if it's 160 and 80. 160 and 80 for this situation. Enter. Good job, Mr. Bierschbach. Okay, so why don't I put this assignment out there? This is all we have for today because I know some of you have to go back to that last assignment and finish some stuff up. Okay, so there we go. Pause. On Wednesday,